Chapter 3, first we're going to talk about measures of center. So our measures of center are actually mean, median, and mode. Mean, which is an average, the median, which is just the middle value in a list of data that's sorted, and the mode, which is the most frequently occurring value. To find the median, you just want to find the middle value when you've got the original data arranged in order of magnitude, so either from smallest to greatest or from greatest to smallest. The important thing about the median is that it's not significantly affected by extreme values. So if you have a value that's a lot larger than the rest or a value that's a lot smaller than the rest, it won't affect the median by very much. So to find the median, first you have to sort the values, arrange them in order. Then you do two different things depending on whether you have an odd number of data values or an even number. If you have an odd number, then you just find the number that's located in the exact middle of the list, which there will just be one right in the middle of the list. If you have an even number of values, then there are actually two values that are in the middle of the list. So you have to find those two and then just average them. So you want to go halfway between those two values that are in the middle of the list. Here are a couple of examples. In this list, we have 6 values. That's an even number, so we're going to have to find the 2 in the middle. First, we have to sort them. So here they are sorted from smallest to greatest. The 2 in the middle are the 0.73 and the 1.10. So we're going to find the average of those two by adding them together and dividing by 2. So that gives us a median of 0.915. The rule of thumb here is to round to 1 decimal place more than you had in your original data. Since our original data had 2 decimal places, we're going to round this to 3 decimal places. Now another list, if we have this list, it has 7 values. That's an odd number, so we can just find the one in the exact middle of the list. Again, the first thing to do is sort the list. The one exactly in the middle is the 0.73, so that would be our median. Okay, the mode is just the value that has the greatest frequency. So in other words, it's the value that occurs the most. And a data set can have one mode, it can have more than one, or it can have no mode if there's no value that's repeated. One important thing about the mode is that it's the only measure of center that we can use with developmental data. If we just have categorical data, then this is the only way that we can tell anything about the center of the data. So just some terminology. Bimodal means that we have 2 different modes. Multimodal means that we have more than 2. And no mode means that there's no value that's repeated. So here's some examples for modes. In this list, our value of 1.10 occurs twice. So our mode is 1.10. In this list, we have 27 that occurs 3 times, and we have 55 that occurs 3 times. The other 2 don't occur as many times. That gives this data set 2 modes, 27 and 55. And finally, in this last example, there's no value that's repeated, so there's no mode. Then we have measures of variability. The first one, and usually the easiest to calculate, is the range. That's just the largest value minus the smallest value. Then we have the standard deviation, and this basically gives us an average of how far the data values are from the mean or from the average. And finally, the variance. The only reason I list this is that it does ask you for this in the homework in a couple places. This is just the square of the standard deviation. So if you've already found the standard deviation, just square that number and that will give you the variance. Now for the standard deviation, this is a measure of variation of values about the mean. So it tells you how far in general the values are from this. Here's the formula for the standard deviation. This is the shortcut formula, believe it or not. Like I said down here, this is a shortcut. Oh my gosh. So don't worry about learning this formula. Don't worry about using this formula. We will be using technology instead. I will put a video out on Angel for you that shows you how to use your TI calculator if you have one to find the mean and standard deviation. It's really pretty easy. The other thing that you can do while you're doing your homework is that you can use StatCrunch. There's actually a StatCrunch button on most of your homework problems. And if you go through and do your Check 1 assignment, that will show you how to find the mean and the standard deviation really easily just using StatCrunch. What's more important is that you know some of the properties of the standard deviation. So I don't care if you can use that sticky formula on the last page and calculate it. What I do care is that you can look at standard deviation for something and tell me what it means. So again, it's a measure of how much the values in the data set vary, how far away they are from the mean in general. So if we have a few values that are very far away from the mean, that can increase the standard deviation by a lot. So it's going to affect the standard deviation dramatically. The other thing about the standard deviation is that the units for the standard deviation are the same as they are for the original data values. So for example, if your original data is in dollars, then your standard deviation will also be in dollars. So here's an example for standard deviations. In this one, we had 2 bank branches where they had different systems for customers waiting in line for tellers. One where the customers wait in individual lines at 3 different teller windows, and one where all the customers get in a single line and then they just go to the next person, the next teller who's available. There was a study done about the wait times for different customers. So branch 1, they actually observed 125 different customers, recorded their wait times, and then here are the descriptive statistics. And again, this is from StatCrunch. This is how easy it is. You just put the values in and click a couple buttons, and it'll give you all this information. So this one, we have the mean. Notice it also gives you the variance. Here's the standard deviation. So that's what we're looking at here. So our standard deviation is about 1.37. In branch 2, where the customers waited in one single line, the standard deviation is only 0.93 approximately. So the means are really close. We have a mean of about 5.3 in each case, but the standard deviations are quite a bit different. Since the standard deviation for branch 1 is bigger, that means that the data was more varied. So there was more variation in how long the customers had to wait. The other thing that you can look at as far as variation is the range, which it also gives in this display. Notice that the range for branch 1 was 7.5, so the minimum was 2.1 minutes and the maximum was almost 10 minutes. For branch 2, the range was only about 3.5. The minimum wait was 3.5 minutes and the maximum was 7 minutes. So again, there's not as much variation in the wait times for branch 2. Okay, here's another example for standard deviation for looking at a histogram. Notice that in this one, we've got quite a few data values over here, kind of on the small end. We've got one over here that's farther away from the others. So we can kind of see in this histogram that the values are somewhat spread out. So in this graph on the left, we can see that the data values are kind of spread out. There is kind of a bunch in the middle here, but we've got a lot of variation. So there's a big range here. But in this graph on the right side, we've got, for the most part, all of the data values are bunched between 3.5 and 7. So this one has a lot less variation than the one on the left. And that means that the standard deviation would be smaller. Okay, now we have measures of relative standing. And these would be the z-score, which tells you the number of standard deviations a value is away from the mean, so either above the mean or below the mean. A percentile, which tells you how many values are less than a specific value. And a quartile, which is just a special case of a percentile. So a measure of position, a z-score. This is the number of standard deviations that a given value x is either above or below the mean. If the value is above the mean, then the z-score will be positive. If it's below the mean, the z-score will be negative. And here are the formulas. Now this depends on what notation you're using. The x with the bar here, or the mu, which is a Greek letter, either of those two stand for the mean. S, or the sigma, either one of those two stand for standard deviation. So you can plug things into this formula, and once you find a z-score, kind of the rule of thumb is to round it to 2 decimal places. So here's an example for z-scores. In this one, we're actually comparing 2 test results. And the tests were different. They had different means, different standard deviations, and we want to know which score was actually better. So what we're going to do is compare the z-scores to tell us which one had a better relative position. So if we find the z-score for the first test, the score was 72, the mean was 80, and the standard deviation was 12. So to calculate the z-score, we're taking 72 minus 80, dividing by 12, and that gives us 0.67. For the other test, the actual score was 19, the mean was 20 and the standard deviation was 5. So if we calculate that, we get 0.2. So the first one, the 0.67, is actually a better z-score. It's a larger z-score. That means that that test score was relatively better. Now, when we look at z-scores, that can tell us whether something is an outlier or not. An outlier is a value that lies a long ways away from the vast majority of the other values in the data set. Now, outliers can be problems if we're looking at the mean for a data set. If there is an outlier or more than one, that can have a very dramatic effect on the mean. It can make the mean much bigger, or it can make it much smaller. It's also going to have a dramatic effect on the standard deviation. Any value that's farther away from the mean is going to make the standard deviation larger. Another thing it can do is have a dramatic effect on a scale of a histogram, so that you can't really tell what the data set looks like very well. So if we're talking about z-scores and outliers, in this book, we can define an outlier as a value that's more than 2 standard deviations away from the mean. And the book calls this an unusual value if it's more than 2 standard deviations away from the mean. And to connect this with z-scores, that means that the z-score would have to be less than -2 or greater than 2. So in your homework, when it asks you about minimum and maximum usual values, you use the mean and the standard deviation that they give you to find these. The minimum usual value is 2 standard deviations below the mean, or is the mean minus 2 times the standard deviation. The maximum usual value is 2 standard deviations above the mean, or in other words, that's the mean plus 2 times the standard deviation. So in the homework, they'll ask you about the range of values. They'll ask you for the minimum and maximum usual value. So use these formulas to find that. And then if the value is outside of that range, if it's not in between the two, then the book considers it an unusual value. Okay, percentiles. These tell you about the relative position of something within a whole set of data. So the way we find the percentile of a value is we find the number of values that are less than that data value in our data set. We divide it by the total number of values, and then we multiply that times 100. And we're always going to round a percentile to the nearest whole number. So here's an example. We've got the durations in hours of a random sample of flights of the space shuttle program. So actually the first thing, if we want to find the percentile for the value 191 in this data set, here's our data value we're interested in. What we need to do is find out how many values are less than that. So it would really help if we first put our list in order from smallest to greatest. So if we start with our smallest value, it turns out there are actually 4 values smaller than the 191. So we divide 4 by the total number of values, which was 15, multiply that times 100, and that gives us 26.7. We're going to round this to 27. And that means that 191 is the 27th percentile for this data set. Again, what that means is that 191 is a higher value than 27% of the values in the set. Okay, now if we want to calculate what a certain percentile is for a data set, in other words, what's the value for that percentile, then we have to sort the data from smallest to largest, and we have to calculate our index, which really tells us the position of the data value. So to do that, we take whatever percentile we're looking for, divide it by 100, and multiply it times n, which is total number of data values in the set. If this doesn't come out to be an integer or whole number, we round up. And this gives you the position of the value in the sorted list. If the value is an integer, then we have to basically average the value in that position and the value in the next position up. So here's an example. We have our list of flight durations again, and we want the 75th percentile for the data. First, we're going to sort the data from smallest to greatest. Then we're going to calculate our index. So we take 75, because we want the 75th percentile, divide by 100, multiply that times 15, because there were 15 values in the set. That gives us a value of 11.25. Now, since it's not an integer, we're going to round up to the next integer, which is 12. That means that our 75th percentile is the value in the 12th position. So if we count, we've got our values here, and if we go up to number 12 in the list, that would be 266. So that's our 75th percentile. Now, quartiles are just special cases of percentiles. The first quartile is the same as the 25th percentile. So that tells you where the lowest 25% of the data is. The second quartile is the 50th percentile. And notice this is really the same as the median. So this divides the data set in half. And the third quartile is the same as the 75th percentile. So this tells you this is the dividing line between the bottom 75% and the top 25% of the data. So when we talk about a 5-number summary, this just is 5 different values. So we take the minimum value, the first quartile, the median, the third quartile, and the maximum value. And once we have that 5-number summary, we can use that to construct a box plot. The box for the box plot has Q1, the first quartile, the median, and the third quartile, Q3. Those are what goes in the box. And then the whiskers, which are the little lines that go on either side of the box, the length of those depends on which textbook or which software you're using. In this book, the whiskers go all the way to the minimum value on one side and the maximum value on the other side. So here's an example of a box plot. So in this case, 61.5 would be the first quartile. The median is just represented by a line in the middle of the box. That would be 63.3. The third quartile would be the 64.95. So those 3 make up the box. And then this whisker goes down to 56.33. So that would be our minimum value, and our maximum value would be 70.13. So this whisker would go all the way up to there. And this one, because the box is pretty even and it's pretty much in the middle between the maximum and the minimum, this data set would have approximately a normal distribution. Now, if we were going to draw something with a skewed distribution, that would be something like this. Skewed is going to mean that, for example, the median might be way on one side of the box or on the other side of the box. And it could also mean that the whiskers are kind of uneven. So this could be an example of a skewed distribution. So this one would be skewed the other way because the median is closer to the first quartile. So there's another example of something that could come from a skewed distribution.